Hi guys. So today we are going to review some things about exponents, but we're also going to review some things from Algebra 2 about logs, which if you remember are very similar to exponents. So before we get started, we are going to start to look at some basic exponent things that you need to know how to do without a calculator. So our first quiz in this unit is going to be our first non-calculator quiz. So there are a few powers you really need to be familiar with if you aren't already, and those are all the ones that are written up there at the top. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. 3 squared is 9, 3 to the 3rd is 27, 3 to the 4th is 81, 4 squared is 16, 4 to the 3rd is 64, 4 to the 4th is 256. That one's not going to come up as often, but 5 squared is 25, 5 cubed is 125, 5 to the 4th is 625. Then you also want to be familiar with basically everything squared up through about 15. And then you want to do 10 to the anything because that's pretty easy. 10 to the whatever power, that's how many zeros it will have. So 10 to the 3 is 1 with 3 zeros. 10 to the 7th would be a 1 with 7 zeros. So a lot like your scientific notation or your sig figs from science probably. So those are the ones you guys really need to be familiar with that are going to come up a lot when we do logs and a lot when we do these exponent rules. So this next part is really just some review from Algebra 1, a little bit from Algebra 2, and we're going to look at some exponent properties. So if you have two exponents with the same base that are multiplied together, you can add those exponents together. So x to the 7th times x to the 8th would be x to the 15th. Y to the 3rd times y to the negative 1 would be y squared. So they have to have the same base, and then you add those exponents. Negative exponents take whatever has that exponent and moves it to the other side of a fraction. So 5 to the negative second is 1 over 5 to the second, which we can say is just 1 over 25. Now be careful that you only move the thing that has the negative exponent. So in this case, the 3 does not have an exponent. The 3 will stay. The x does have an exponent, so the x is going to move. If it's already at the bottom, again, the negative exponent would move it to the top. So that would become 4 squared, which is 16. And again, only move what has the exponent. That negative 6 does not have an exponent, so the negative 6 is not going to move. It's just the x that is. Fraction exponents, you guys probably saw for the first time in Algebra 2. So the way the fraction exponents work, the bottom number is the root that you take. The top number of the fraction is the power that you're raising this to. Now, if you're actually trying to evaluate these, you want to take the root first. It's a lot easier to get to a smaller number. So we're going to take the second root, or the square root of 4. So the square root of 4, and then raise it to the 5th power. So the square root of 4 is 2, and 2 to the 5th power is 32. So let's try another one of those. Again, the bottom number is the root. Think about trees. Okay, trees have roots at the bottom. So the bottom number is the root. So the second root of 9, the square root of 9 is 3. Then raise that to the 3rd power. 3 to the 3rd is 27. All right, now let's combine these together with a negative. Negative exponent is going to move this to the bottom. Okay, the bottom number is the root that we take. So we're going to take the cube root of 27. So this is why it's really helpful to be familiar with those powers. The cube root of 27 is 3. And then we're going to raise it to the 2nd power, and I get 1 over 9. All right, 8 to the 2/3, that's the cube root of 8. So what number times itself 3 times gives you 8? The cube root of 8 is 2. Raise it to the 2nd power, and that's 4. All right, 5 to the 0 power, anything to the 0 power is 1. These next two, I think we've talked about this before. This is really important, especially when you're plugging things into your calculator. There is a difference between these two questions. Negative 7 squared is a negative 7 squared, which is 49. Whereas negative 7 in parentheses squared means negative 7 times negative 7, which is a positive 49. There is a difference between those two things. It's all about your PEMDAS and your order of operations. All right, let's try the next one again. Negative exponent, it's going to flip that fraction. So this is going to become 9 over 16 to the 3/2 power. When you have a fraction like that, both the top and the bottom get the exponent. So this will be 9 to the 3/2. So the square root of 9 is 3. 3 to the third is 27. The square root of 16 is 4. 4 to the third is 64. And then the last property, whenever you have parentheses, everything that's in the parentheses is going to get that exponent. Now, what you'll notice, this is not the same thing as this. You don't distribute the negative if there's a plus or a minus in the middle. There are no pluses or minuses here, so this is all one term. If it's just one term, each kind of part of that term will get that exponent. So this is 2 to the third. We multiply these exponents, so I end up with 8x to the 6th y cubed. All right, and then this last one, same idea. This is all one term. There's no pluses or minuses in the middle. So this is going to be 2 squared, multiply that exponent, and then anything to the 0 power is just 1. So that's y to the 0. That's just going to be 1. Well, now your last property, when you have exponents top and bottom, you can subtract them. So this would become 1 over 4x to the 5th. So the reason it's really important for us to understand these exponent rules well is because exponents really help us to do logs. So logs you saw for the first time in Algebra 2. So if you remember, a log is the inverse of an exponent. So this is an example of something in log form. So in log form, the little small number, or the small font number, I should say, is the base, right? The number that comes after that is what's called the argument, okay? The argument. What you're actually taking the log of is called the argument. And then the number over here is just the exponent. The way you rewrite this in exponential form, you kind of go in a circle where you take the base and then you flip the other two numbers. Okay, so you take the base and you flip the other two. So b to the x is equal to y. Some things to know about logs: the base is not going to be 1, and the base also has to be a positive number. Same thing for the argument. The argument has to be a positive number as well. It's going to come back up when we get to solving. All right, so let's go ahead and rewrite a few of these in exponential form. So start with the base and then flip the other numbers. So 6 is the base of the log. The base of the log is the base of the exponent. And then I'll flip the other 2. Or again, you can kind of go in that circle pattern, whichever way you've learned it. So in that circle pattern, 7 to the 0 is equal to 1. 21 to the 1 is equal to 21. 1/5 to the negative 1 is equal to 5. So that's how we rewrite it. So again, the base of the log is still the base of the exponent. The base of the log is still the base of the exponent. So now let's go in the opposite way. Let's write it in log form. So the base of the exponent, the base was 9, so the base of the log is 9. And then I flip the other two numbers. So on the next one again, base of the exponent is the base of the log. Flip the other two numbers. All right, base of the exponent is base of the log. Flip the other two numbers. Base of the exponent, base of the log. And flip our other two numbers. So whichever way you learned it, whether with draw the circle, write the base, however you know, just make sure you're comfortable converting between these two forms. All right, so what we're going to do now is actually evaluate these. And again, you're going to evaluate these without a calculator. Okay, you're going to evaluate these without a calculator. On your quiz, like I said, it's going to be a non-calculator quiz. So when you're evaluating a log, think about what this would be in exponential form. 2 to the something. So 2 to the something is equal to 8. So again, in exponential form, let's pretend this equaled x. 2 to the x is equal to 8. You're trying to find the missing exponent. So 2 to the what power is equal to 8. This is why it's going to be really helpful for you guys to be familiar with some of those basic powers from the very beginning. So in this case, 2 to the third is equal to 8. All right, let's look at b. Again, pretend it's equal to x, write it in exponential form. 7 to the x equals 49. What's my exponent? Well, 7 squared is 49. All right, log base 4 of 1. 4 to the something is equal to 1. Well, anything to the 0 power is equal to 1. All right, 8 to the something is 1 over 64. Now we're getting into the harder ones where we're getting into our exponent rules. So this turned into a fraction. Negative exponents will flip fractions. So this has to be a negative exponent. And to get from 8 to 64, that's squared. So this will be negative 2. All right. 1/3 to the something is equal to 27. Again, we're going from a fraction to a whole number, so I need a negative exponent. So a negative exponent's going to flip it. 3 to the third is 27. All right. 27 to the 1/3. Now this one's kind of tricky because this is going to need two things. So the first thing that I'd have to do on here is I do need a negative exponent again, because that's what's going to make this a fraction. So to get from 27 to the fraction, I need a negative. To get from 27 to 3, though, I'm actually getting a smaller value because I'm taking a root. To get from 27 to 3, I can take the cube root of 27. The cube root of 27 gives us 3. Then we have to write cube root as an exponent, which is a fraction, which is 1/3. All right, let's look at the next one. 81 to the something is equal to 9. So again, to get from 81 to 9, we're taking the square root of 81 is 9. The square root of 81 as a fraction, as an exponent, is 1/2. 81 to the 1/2 means square root. All right, the last one's really hard, so we're going to go ahead and write this one out. Now, if you're really good with your mental math, you may be able to figure out what root to take and what power to raise it to. And if so, that's great. But I think the easier way to do this is to solve it like an equation. Let's rewrite these two numbers in terms of the same base. So what I mean by that is 27 is the same thing as 3 to the third. 81 is the same thing as 3 to the fourth. So what I'm going to do is I'm going to rewrite those two numbers. 27 is 3 to the third, and it's 3 to the third to the x. 81 is 3 to the fourth. Well, if those two things are the same, the only way they can be the same is if the exponents are the same. So 3x has to equal 4. So x has to equal 4/3. All right, so let's look at some special bases. So there are two special bases with log. You have the common log and the natural log. Okay, common log basically means you see log, but you don't see a little base written. If you don't see a base written, the base is 10. So we're going to evaluate these just like we did before. So pretend it equals x, rewrite it in exponential form. The base there is 10. So 10 to the x equals 1,000. Well, to figure that out, again, with tens, you count the zeros. 10 to the third because there's 3 zeros. All right, again, rewrite it in exponential form. 10 to the something is 1 over 100. Well, to get to a fraction, I need a negative exponent. And then to get from 10 to 100, it's squared. So it's negative 2. All right, let's try this next one. 10 to the something is the cube root of 10. So we have to figure out what's cube root as an exponent. Well, cube root as an exponent is 1/3, the third root. That's my exponent. All right, and then the last special base is the natural log. Natural log is a base of e. So if you remember from Algebra 2, e is a constant. It's kind of like pi. E stands for about 2.718. That's what e is. So what you'll never see really written is log base e, like with a little e there. But that's really what ln is. And if that's easier for you, rewrite it. Okay, so ln e means log base e of e. So to rewrite this in exponential form, e to the something is equal to e. Well, in order to get the same thing, that exponent has to be 1. All right, let's do the next one. Log base e of 1 equals something. E to the something equals 1. That something is 0, just like it was before, because anything to the 0 power is 1. All right, again, ln e, that means log base e of e to the 7th. E to the something is equal to e to the 7th. Well, that something has to be 7. And then last one, e to the something is the square root of e. So again, what's square root as an exponent? Square root as an exponent is 1/2. All right, so those two little properties that are listed over there, you probably have already seen this. You don't have to know them, but that may help you recognize if the base and the argument are the same, it's going to be 1 because anything to the first power is itself. Same thing, if the argument is 1, it doesn't matter what the base is, it's going to be 0 because anything to the 0 power is 1. All right, so the last thing we're going to look at is how to evaluate these with a calculator. Now again, on your quiz, it's going to be non-calculator because we'll get some of those nicer values that you can evaluate without one. But some of these, it's impossible to figure it out without a calculator. So for example, log base 3 of 7. 3 to the something is equal to 7. I can't figure that out on my own. This is a case where we have to use a calculator. So the hardest part about this is remembering where to find it, because if you look on your calculator, you'll see log and ln, but you won't see log with a different base. So we need to find the log AB function. So let me go ahead and get my calculator. Okay, so the way that you find logs to the different base, what you're going to do in your calculator, as long as you can see that normal kind of menu there where it says jump, delete, MAT, and math. You're going to start by going to math, which is F4. Then you'll see log AB at F2. That is going to allow you to enter a log of a different base, and then you can actually find what this is. And again, just to show you, okay, 3 raised to that power gives me 7 exactly. So that's how we can evaluate these with a calculator. If you want to do ln of 4, so ln is right there next to log. So kind of, I'm not sure if you can see my cursor. So if you can't see my cursor, so ln is this button right there. Regular log base 10 log is right next to it. All right, so ln 4. Sorry guys, my iPad's going real slow here. But now I have at least I have the Calxio emulator here. So ln 4 gives me that decimal, and we can just round at this point. If I want to do the natural log of 3e, so I would do ln, and one thing I need to make sure I do is I need to open a parenthesis, okay? Because again, the 3e is all the argument. That's what I'm taking the log of. So I'll do 3, then where you find e is right above ln. So I'm going to do shift ln, that gives me e. Now this is just e to the first. It automatically puts an exponent on there, so I'm going to put a 1. And that'll give me the natural log of 3e. All right, log of 8. Now this is log base 10 log. So you can either do log AB, and you can fill in a 10 there if you want. Or if you want, you can just use the regular common log button, which again was right there next to ln, in between ln and x. That's where the log button is. And you can do log 8. All right, then the last one on there, again, we would have to do log AB. So again, if you don't see that normal menu, you can just press exit, math, log AB. If you ever forget where that is, you can always go to the catalog to help you find it. So if you do shift and then 4, that has the catalog on it, this is all the functions you have in your calculator. So if I want to find log, I don't remember where log AB is, I can do alpha L, which is going to be right above that arrow. And that takes me down to the L's. And then you'll see log AB. So log AB is what allows you to put that different base in. All right, so that is it for some log review. Again, be really comfortable with those exponents and evaluating these exponents without a calculator. We'll do some practice in class on that.